let's write the given thing first. It says AB, AC, and median AD of triangle ABC are proportional to PQ, PR, and PM. PQ, PR, and PM of triangle PQR. So they are proportional. Sides are proportional means this ratio is equal, and this is given. I think this is the only thing given, and we are given these two figures, triangle ABC and triangle PQR. Look to prove them similar. Two sides are already in proportion, AB to PQ. AB and PQ are in proportion, and AC and P are in proportion. If we could show angle, no, this angle is also equal to this angle. Means if we could show angle BAC is equal to angle QPR, then by SAS, these two triangles would be similar. Well, to prove that, we will need to do a little bit of construction. And the third information we are given is AD and PM in proportion. So we are taking that to construct further. So we are going to construct, or we can say AD, we are extending AD to a point, say E, such that AD and DE are equal. So let's say this point here is E, and we are extending in such a manner that AD and DE are equal. And then join BE. Can join BE? Yes. B to E. Similarly, we can do extension here. PM is extended to a point, say PQR. Let's say this point is S. And then join QS. This point S is joined with S. So we are extending in such a manner that PM is equal to MS. Now, one thing we can easily see, since AD is the median, so BD and DC will be equal. Similarly, PM is a median, so QM and MR will also be equal. Let's show it by two lines. Okay. Now, using this information, we can prove triangle ADC and EDB are congruent. Look, side, angle, side, vertically opposite angles, and the two sides are equal. So let's write that. We are going to write all that first. So what we are writing is AB by PQ is equal to, let's say, okay, just a moment. All right. So BD, which is D is the midpoint, BD is equal to DC. Okay, BD and DC are equal. And by construction, we have taken AD is equal to ED. This is by construction. Well, from there you can say AD equal to ED, and third angle also vertically opposite angle, which is angle ADC is same as angle BDC. Vertically opposite angle, right? Vertically opposite angle. And this was given, and this is construction. This comes from construction, and this thing was given. All right. This means we can say triangle ADC is congruent to triangle. Whenever we write congruency, we should write corresponding sides and corresponding angles in the same position. Corresponding to angle A is angle E, so this should be EDC. D is common. EDC. Well, once we have proved these two triangles congruent, we can use congruency to compare their side. I mean, of course, we can say the side AC, first third, is same as AC is same as, oh, did we write it wrong? D is congruency, no? EDB, yes, let's write it. Let's correct it. EDB, triangle EDB. So we can say the corresponding sides are equal, means, well, we can say AC is same as first third and EB, first third. Okay. And also, let's name these angles here, right? In the figure, we can name the angles, and we would like to take the angle also. This angle over here and this angle. Because ultimately we want to show this angle A is equal to angle P, no? That is our goal. So we are relating these two angles also. If I name this angle as angle 1 and this is angle 2, so we can say angle 1 equal to angle 2. Along with this, we can say angle 1 is equal to angle 2. That is by, let's name this equation 1, and this comes from CPCT, corresponding part of congruent triangle. Just like we proved these two triangle ADC and BDE similar, means ADC and EDB congruent, in the same manner, we can prove these two triangles are also congruent. So, okay, let's write it. Now we will go in triangles. In the similar manner, we are taking triangle, we can say similarly here, no? Similarly, QM will be equal to MR, and PM is equal to SM. This was construction, and angle PMR is same as angle QMS, vertically opposite angle. So you can say triangle PQR, PMR is congruent triangle SMR. Okay, from there also you can say PR is equal to, we would like to relate these sides, you know, PR will be same as QS, PR will be same as QS, and let's name these angles as well. So 1, 2, let's name this angle is 3, and this angle over here is 4. So can we say angle 3 equal to angle 4? Angle 3 is equal to angle 4. Let's name this equation 2. And this congruency is by SAS, no? Side angle side. You must write this congruency. Did we write up there? Yes, here also we should write SAS. Here we should write, this is side angle side. Okay, so once we have proved that angle 3 equal to 4 and PR is equal to QS, this gives you a lot of information to now find some relation in triangle ABE and triangle PQS. Once we find relation, actually relation is such that they are looking like similar. So once we can prove them similar, we can relate this angle over here. You see the part of angle A, the part of angle P. If you could prove them also equal, then maybe we can find angle A is equal to angle P. Ultimately, we can show that, and we are done. So what we are going to do is we are going to prove next. Look, the first step was we did construction. We extended AD to a point E, and then we found two congruent triangle. From there, we took some information, and now we are taking here two similar triangles as well. And from there also we will take some information, and then we would conclude and see if we can conclude that Yes. So what information we have here now? Look, we were given in the starting. We were given. We are going back to that given thing. We were given AB divided by PQ was same as AC divided by PR, wasn't it given? And it was same as AD divided by PM. This was given in the starting. So we're taking that. Now, in place of AC and PR, look the value. Look, PR is QS here. In place of PR, we can write QS. And also in place of AC from up there, AC is same as EB. Look, this side AC and BE is same. PR and QS is same. That is what we are going to use here. Means in place of AC, we are going to write what? Let's write AB by PQ as it is. This implies AB by PQ. It's same as in place of AC, we are going to write B because in equation 1, we proved that. And in place of PR, we are going to write QS. PR is equal to QS, equation 2, you see. And AD by PM, can we write it 2AD by 2 PM? Look, 2 and 2 gets cancelled, so that will have no effect at all. But 2AD can be written as AE. All right. So what did we get? AB by PQ is same as BE by QS. And this is same as AE over PS. That's very easy. Yeah. So now we have seen how we have shown that triangle ABE and PQS had sides in proportion. That means they are similar. Well, so we got that triangle. Can we say here? Therefore, triangle ABE is similar triangle PQS. All right. So AB is similar to PQS. Once they are similar, let's take angles of those similar triangle as well. So what we are going to do is 1, 2, 3, 4. Let's name this angle is angle 5, part of this. Yes. And let's say this is angle 6. Can we say angle 5 is equal to angle 6? Correspond. Yes, we have shown them to be similar. That's right. Why we are showing them similar. Just a moment. Yes. So they are similar by SSS. No, we should write here SSS. In the bracket, this is SSS similarity. All right. And once we have shown these two triangles similar, we can say angle 5 is equal to, this means angle 5 is equal to angle 6. Also, we can say angle 2 is equal to angle 4. Now, equation 1, 2, let's say this is equation 3, and let's say this is equation 4, right? These both angles we have shown equal by corresponding angles of similar triangle. Corresponding angles of similar triangle, right? So angle 5 equal to angle 6, 2 is equal to 4. But in equation 1 and 2, I have angle 1 is equal to 2 and 3 is equal to 4. Right? Means in place of angle 2, we can write angle 1. Would you like to see? In the first proof, we had written here, you see, angle 3 is 4 in the second one, and angle 1 equal to 2. Yes, we are going to use that. So in place of angle 2, we can write angle 1. This implies angle 1 is equal to, in place of 4, we can write angle 3. 4 equal to angle 3. Let's say this is equation number 5. Can we add equation 3 and 5? Look, equation 5 plus 1, add. Simply add, right? Add equation 3 and 5. What do we get? 5 plus 1, angle 5 plus angle 1. We can write angle 5 plus angle 1 is same as what was the other value? Angle 5 and 1, 6 and 3 equal to angle 6 plus angle 3. Angle 6 plus angle 3. Look carefully. What is angle 5 plus angle 1? Angle 5 plus angle 1 is angle BAC. BAC is same is equal to an angle 6 plus angle 3. Look, this is 6, this is 3. 6 plus 6 angle 3 is angle QPR. QPR. That is what we were looking for in the beginning. We said no, two sides are already given in proportion. If we could prove these two angles are equal, we can say the triangle ABC and triangle PQ are similar. So we are done, right? So this is we have and we means we have seen here that triangle ABC and triangle QPR are equal, and also the given information in the beginning we should quote that as well, like AB by PQ is equal to AC by PR, and from these two statements you can say this implies triangle ABC is triangle similar to triangle PQR.